All right, good morning, everyone. We will go ahead and get started here. I guess I shouldn't say good morning, depending on where you are on the globe. Good morning, good afternoon, good evening, good day. We appreciate your time. We know everybody's busy, and we're greatly appreciative of you joining us today. We'll go ahead and dive right in. We'll give a brief introduction of GeoSolutions and who we are, and then I will transfer it over to Andrea, and we will dig into what is new with GeoServer 2.22. For those of you not familiar with GeoSolutions, we're composed of core developers and many of the core code committers for open source products such as GeoServer, GeoNode, and MapStore. This is a very high concentration of open source geoengineering expertise made directly available to you. Our global headquarters is in Italy, and we're incorporated in the United States. For those on the government side, we're fully registered on SAM as a small business entity as GeoSolutions USA Corp. We support these 4 core products and many of their input-output plugins and associated protocols. GeoServer, which we're focusing on today, is an open source server for sharing geospatial data. Designed for interoperability, it publishes data from any major spatial data source using open standards. MapStore is an open source, highly modular WebGIS framework developed by GeoSolutions. It is used to create, manage, and share maps, dashboards, and stories created by mixing geospatial contents served from sources like OpenStreetMap, Bing, or from servers adhering to OGC standards like WFS, WMS, WMTS, etc. GeoNode is a web-based application and platform for developing GIS and for deploying spatial data infrastructures. Today, we're focusing on GeoServer, but I do want to emphasize that we've been making much progress with MapStore and GeoNode, for which previous webinar recordings are available on our YouTube channel and our website blog. GeoNetwork is a catalog application to manage spatially referenced resources. It provides powerful metadata editing and search functions, as well as an interactive web map viewer. It is currently used in numerous spatial data infrastructure initiatives across the world. At the bottom there, our offer. So how do we stay in business? I get asked all the time about our business model, especially given that we're in open source. Enterprise support services is commercial support for these open source products. We can provide full technical assessments, for example, of GeoServer and associated environment performance, providing a detailed report on where performance can be improved, how to best structure data, optimization for security and performance, etc. If you're already working with OpenGeo products, you can lean on us as core developers if you require a deeper level of support, or we're here to help you get up and running with full installation, deployment of any of these products, migrating, modifying from current GIS to a hybridized open interoperable solution to save cost and increase capabilities. Deployment subscription provides 99+% uptime, where we proactively address performance updates and stay ahead of potential issues through monitoring customer GeoServer instances. Customized solutions, this could be anything, any new custom development work or integration that is needed to extend the functionality of GeoServer, for example, for your specific operations. Typically, this is a firm fixed price solution where you tell us what you need and we build it, and the resulting code can be released as part of the open distribution. And finally, professional training. This can be on site, but is also available remotely. GeoSolutions has regularly scheduled trainings. You can see our website for the schedule. We also have a full catalog of training courses available on our website specifically for your organization. And these trainings are intensive and designed to enable your own capabilities internally. Our objective, our value proposition, is to perform as your open source geospatial development team of engineers, helping you reduce costs and increase your capabilities through technical support, custom development, and knowledge transfer. We've supported and currently support customers all over the globe, as you can see here from the map of where our customers are located. Each customer has specific requirements. No project or operation is exactly the same. However, this demonstrates not only the breadth and range of our customers we support, but our experience in working across a variety of industries, domains, and problem sets. You can see down at the bottom that we've supported or are supporting the UN, World Bank, several Earth observation companies, NATO. We've supported US Navy, NOAA, other US federal agencies, and larger Earth observation companies such as Maxar, MDA, and others. As you see here, we have extensive experience supporting customers in Earth observation, defense, emergency management, everything from ocean vessel tracking, where we're supporting the tracking of 200,000+ vessels at any given time, to real-time wildfire mapping and evacuation route updating, to real-time high-definition mapping for autonomous vehicle navigation. Anything requiring the management and movement of massive vector and raster spatial temporal data from sensor to end-user applications is our bread and butter. We're active OSGeo, OGC, and USGIF members. We're obviously active sponsors with OSGeo. We participate and contribute to OGC innovation programs such as the test beds and disaster pilots, continually extending and developing new open source capabilities to address real-world problems. We're also USGIF members, supporting the federal government, contractors however we can, with GeoInt-focused operations. And you'll find us at conferences, workshops, and industry events organized by these industry associations. I do want to mention, feel free, I will post my contact information and the info at geosolutionsgroup.com email. If you ever have any questions, aside from all this sales mumbo jumbo, we know a lot of folks are out there working in open source geo that might not know who they can lean on, or they might have questions about performance, security, etc. I'll post some contact information so you can get in touch with us anytime. We're always here to support your operations and help out wherever we can. So with that, I'm pleased to introduce winner of the prestigious Soul Cats Award for his contributions to open source geo, Andrea Aime. Andrea, go ahead and take it away.
Hello everyone. Welcome. So today we are going to have a look at state of GeoServer 222 with some information from GeoServer 221 and some updates about what's cooking for GeoServer 223 while we are at it. Now, let me share my screen. Ryan, can you confirm we are looking at the slides?
Yes, sir, I see it.
Thank you. Okay, so let's have a look at what's cooking in GeoServer land. So this presentation is brought to you by me, and it was originally developed along with Jody Garnett from GeoCat, although it has been updated in quite a few slides, well, to give you the latest updates. GeoServer, well, if you are here, you probably know already what it is. Java web application to share and edit geospatial data. We make maps, we deliver raster data, we deliver vector data, we deliver tiles. We do processing, we can do search through CSW, through OpenSearch, and we are underway on the support of OGC APIs, the new wave of protocols from OGC. Quick GeoServer community update, 2022. The project steering committee is made, which is the team that manages the project, that takes the, let's say, the big decisions whenever we have to make a significant change to the project or to the code. We have the PSC voting on such endeavor and providing feedback. And these are the people that are part of the PSC. As you can see, there is a fair amount of people from GeoSolutions itself, Alessio, me, Nuno Oliveira, Simone Giannecchini, they are all from GeoSolutions. We have a set of core committers which are nominated by their peers and trusted to with the ability to review and approve pull requests, which is our mechanism to contribute code to GeoServer. And most of them are also project steering committee, but not all of them. We have a fair amount of core committers which are not project steering committee members. And we also extend a community commit to people that contribute to modules of GeoServer. As you probably know, GeoServer is a highly modular application, and we get people that are maintaining a specific module. We give them commit access on a as needed basis. The newest committer, well, not this week, this slide was updated a few months ago, is Joseph Miller. Joseph got the commit access back in November. In terms of companies that are revolving around the project, we have an organization of 3 types of companies: core contributors, experienced providers, and additional service providers. They are all available at geoserver.org. You can go to our website and find them. You go to support, commercial support. Core contributors are the company that, like GeoSolutions, contribute directly to the project in terms of writing code, but also doing releases, but also looking at security vulnerabilities, evaluating larger changes through PSC membership, and so on. Then we have experienced providers, which can do a bit of everything, starting from coding documentation, but also training and the like. And we know them; they have been around GeoServer for a long time. Even if they are not core contributors, they can provide services with a good amount of experience. And then we also have a list of additional service providers, which is pretty much anyone that wants to be highlighted providing services for GeoServer. And if anyone here in this call wants to be included in one of these categories, please send an email to the GeoServer Devel mailing list and tell us what you are doing and in which category you see your company fitting. And we'll check it out and eventually add your company to the list. In terms of infrastructure, GeoServer relies on a number of services which are provided by a variety of organizations. So for example, geoserver.org runs on GitHub pages. So we rely on GitHub. We rely on GitHub also for the version control. OSGeo is providing our Maven repository, manages our domain names, and the like. GeoSolutions is providing the build server, the one that we use to perform releases, to prepare nightly builds, and to perform continuous integration. The web map that you see at geoserver.org, the sleepy map that you see in the center, is provided also by GeoSolutions through a GeoServer that is rendering OpenStreetMap. And SourceForge. Yeah, SourceForge is still managing our downloads. Why? Well, because we can literally throw a ton of binary at SourceForge and rely on their very large content distribution network, mirrors providing fast access to the binaries all over the world. GeoServer also maintains a set of community modules. Community modules are modules that, well, they are either newborns or they never managed to get to extension status. Typically, developers propose community modules to share an idea, to start working on a concept, and we only make sure that they compile. And eventually they can be proposed as an extension when the author and the functionality and the documentation of the module is good enough. There is a lot of movement in the community area. Oh, by the way, the community modules can be found only in nightly builds. They are not part of releases, as they don't tick all the boxes in terms of quality. As you can see, we have quite a bit of movement. This year, we have been looking at a few modules, like a new JSON support in GeoTools, but also MBTiles for GWC, a libdeflate, a module that speeds up the encoding of, the decoding and encoding of deflate compressed geotiffs and so on. But we also see a fair amount of modules that are no longer maintained or no longer of interest, and they are dropped. And this list is updated in 2022. But if you are on GeoServer Devil, you probably noticed that I personally proposed a dozen modules for removal in the community section before 223 is released, because well, they are getting no traction. We are also getting a fair amount of modules that graduate, though. So there is some selection. The ones that stand up and manage to get to the right quality level, they are promoted to extension, and then you will find them in releases. Now, let's have a look at the GeoServer releases. Sorry. So between the end of 22 and 2022 and the beginning of 2023, as you can see, we are looking at 3 releases: 221, 222, and 223. 221 and 222 are currently being released, and as you can see, you are here close to March 2023. What happens in March 2023? Well, 223.0 will be released. And what's interesting about 223 is that it will require Java 11 as the minimum version. When that happens, 222 will be abandoned. 221 will be abandoned. 222 will become maintenance, and 2023 will become stable. If you are using an older version of GeoServer, please upgrade. Why? Well, first of all, because security fixes are added only to supported versions, and also because we try to pack up improvements and speed ups as we move forward in newer versions. So please don't stay on older versions of GeoServer. I understand that upgrading can be a bit of work or a lot of work. That depends on how much automation you have in your quality assurance for your deployment. If you have a lot, it's actually easy to try and upgrade and see if everything is working fine. If you have a manual test scripts or you don't have test scripts, then it's going to be a bit more complicated, because you upgrade and then you have to hope that everything worked fine, which is normally the case. We make a very conscious effort not to break backwards compatibility, but the occasional bug might happen. So in this presentation, I'm going to cover what's new in 221, 22, and 23, and hopefully I will give you some motivation to upgrade. At the end, sorry, not at the end, at the bottom of each slide, you will see 3 boxes. The one in the middle is the developer that implemented the functionality we're talking about. The green box is about the version of GeoServer that contains that new functionality or fix for the first time. And in orange, the sponsor, that is the company that sponsored the development of such functionality. It might also have a heart. In that case, there was no sponsor. It's a developer that used his own spare time to implement the functionality in question. Okay, we are going to go through by topic. So first of all, distribution and runtime. As you probably know, GeoServer.org has been developing its own Docker image, which has been available for around a year, give or take, maybe a little less. And you can find it for the currently supported versions, so 221 and 222. It has been initially proposed by Luca Pasquali and Niels Bürner from GeoSolutions and Terrestris. And eventually, the effort became the official Docker image. That doesn't mean that you have to switch to it. There are other Docker images out there, like Cartosa has been providing Docker images for a very long time. GeoSolutions has its own one. And they all provide similar functionality, like choosing the GeoServer version, choosing the extensions that you might want, and the like. They differ in the set of default plugins that they pack in the base package. and a few other elements, such as when do you combine the extensions with the main package and stuff like that. I invite you to have a look and choose the version that is best suited to your environment. We have the Windows installer. The Windows installer has been a GeoServer feature for many years, and then around the GeoServer 2.14, we lost the ability to produce Windows installers due to infrastructure vandalism. The build server got attacked, and we didn't have the time and resources to put together the build infrastructure needed to produce the installer anymore. It's not as easy as it seems. You need a dedicated Windows machine. You need a trust certificate that you use to sign the installers and so on. Well, eventually, GeoCat managed to land a small contract to set up a new installer with an updated version of the installer library and automation so that we can generate it through releases and so on. And we are back having a Windows installer in the latest versions of GeoServer. Java 11 has been around for a while, but if you have been installing GeoServer for some years, you probably know that the minimum supported version by GeoServer is Java 8. Well, GeoServer 2.23 will require Java 11, so you will not be able to run on it on Java 8 anymore. In addition, we have experimental support for Java 17. I've heard of people running it in production on the user list. To be honest, I don't think that GeoSolutions has any customer running Java 17 in production, although we know it works. In terms of mapping, what's new in terms of cartography and the like? Well, in GeoServer 2.21, we added this new functionality, which is layer group styles. So if you have been playing with layer groups for a bunch of years in GeoServer, you probably know that it's a concept that allows you to stack a certain set of layers with a style of your choosing and give it a single name. So make it behave as if it was a single layer. The thing is, unlike normal layers, which can have multiple styles attached to them, layer group only had one fixed style, the one that you chose when you put together the layer group. Well, in GeoServer 2.21, you can now create group styles, which are literally just different sets of layers and styles. So if we look at this Ordnance Survey master map example, we actually, in this case, we actually have exactly the same data depicted in different ways in 4 alternative styles. So in this case, the layers are the same, the styles attached to the layers are not, they change. But if you want, you could have also a detailed and a simplified map style in which, well, the simplified map might have less layers, and that would also be legit. So the system should be used in such a way that you switch the style, you get more or less the same information presented in a different way. This functionality is a little technical. So this map that you see in the bottom left is a map of 150,000 vessels in the European area as managed by by EMSA, the European Maritime Security Agency. So each vessel of consequence has a transponder installed that's reporting its position and so on. EMSA collects in real time all this information and has a mandate to produce map even at this resolution where, well, most of the ship positions are cramped all together. And it was pretty slow to draw all of them because, well, GeoServer has pluggable symbology. And the system was looking through the possible symbology provider to find the one that was providing the ship icon. sometimes spending too much effort doing so. So we made it so that you can choose which symbologies provider you actually want to use and in which order you should visit them. If you're trying to render a ton of points, putting the provider that actually provides the icons you use most is going to provide you with a significant speed up. In terms of speed up, again, mosaicing performance. What we always said about the image mosaicing in GeoServer is that the image mosaic can contain as many images as you want, millions, billions, it doesn't matter. Why? Because typically the list of images is really stored in a database that you can index, that you can partition, that, well, you can do things to make it fast, the lookup. What is normally slow is trying to actually put together that many images in a single output, like this image of Africa composed of several hundred smaller satellite images. It's a use case that we never try to support properly because, well, you have to open this many, very many files, load the data, and so on. And so we overlooked the fact that there was actually an inefficiency in the mosaicing code itself. Through USGS, we developed an improvement that, well, on a use case with 300 images, improves the memory usage and performance by 2 orders of magnitude. 2 orders of magnitude means that it's at least 100 times faster, which is a pretty good improvement. Similar, historically, GeoServer has been pretty good at handling images with the normal amount of bands, like 1, 2, 3, 4, but also multispectral images, the kind that comes with Sentinel-2, Landsat, and so on, which are 13, 15, 18 bands, stuff like that. But there is a new crop of sensors out there, hyperspectral sensors, that produce images with hundreds of bands with a very fine resolution in terms of wavelength. Now, GeoServer was not particularly good at handling that particular type of image. And again, we made improvements so that you can band interleave the images, which basically means that each band is stored sequentially in the file as a separate sub-file, let's say, sub-image, and made GeoServer orders of magnitude faster at handling and reading them. So if your use case is having hundreds of bands, and of course, when you try to generate a false color image, you're going to pick 1 or 3 of them, then GeoServer is going to be much, much faster than it used to be handling that particular use case. Also, in terms of cartography, GeoServer 222 comes with a new demo dataset, which is derived from Natural Earth, 1 to 50 million layers, let's say, datasets. And it's included in the built-in data directory, which provides global coverage with a simple map. If you want to have the full set of Natural Earth displayed with a detailed map, then you can go to this repository provided by GeoSolutions called NE Styles, Natural Earth Styles, which covers full cartography of Natural Earth up to 1 to 10 million, which is the highest resolution level that you can get out of Natural Earth. Now let's have a look at data sources and formats. First one that you can find starting GeoServer 221 has been a long time requirement from our users, and eventually, thanks to the Canton of Solothurn sponsoring, we managed to implement full customization of the feature types. What does it mean? It means that, as usual, GeoServer will start providing you with the names of the columns in your database, their type, and so on. But now you can click on the Customize Attributes checkbox and rename the attributes, which is pretty handy if, for example, your source database is Oracle with all the uppercase attribute names, or if it's a shapefile with the nasty limitation of how many, 12 characters per column, something like that. And in addition to that, you can also force a conversion of type, like maybe you have a string column which contains yes and no, and you can ask GeoServer to turn it into a Boolean instead. Eventually, you can also provide your own expression to compute on the fly whatever attribute you want. In GeoServer 2.21, we introduced support for GDAL 3x. Before, GeoServer was supporting GDAL 2x, and this comes with a newer version of the library. The updates have been done by David Blisby from GeoCat. And yeah, this allows GeoServer to leverage the native GDAL libraries from the 3x series. In terms of supporting images in the cloud, we have had a significant amount of improvements on the COG provider, Cloud Optimized GeoTIFF. The idea is that you take a GeoTIFF image, you turn it into a COG, which is really still a GeoTIFF, just with a layout that's optimized for efficient extraction of data through HTTP requests. You stick them on a blob storage, Amazon S3, Google Cloud Storage, Azure blobs, and leveraging, let's say, the cheap storage that they provide. And yeah, this COG support allows you to communicate and fetch data from S3 to GeoServer. The novelty is that initially we only supported S3, but now we also support the Google Cloud Storage and Microsoft Azure. libdeflate is another interesting improvement. libdeflate is a specifically optimized version of the original deflate library. Deflate is a compression algorithm that can be used to speed up compression and decompression times. And thus, it's pretty interesting when you have GeoTIFF files which are compressed using deflate, which is what you normally use when you don't want to alter the contents of the image. Otherwise, JPEG compresses better and it's faster. But if you're limited to deflate, then this means this plugin means that you can get better performance in terms of compression and decompression through GeoTIFF deflated files. Another interesting thing when it comes to raster management is the stack data store. Stack stands for Spatiotemporal Asset Catalog. It's an OGC specification. It's a catalog of spatiotemporal assets. One type of spatiotemporal asset is satellite images, for example. They have a location, they have a time, and they cover a certain area, and a stack catalog can catalog them and allow you to search through them. The interesting bit about the stack data store is that it behaves like a data store. So it talks to a stack catalog and allows you to paint maps of the footprint of the images, SQL filter through them so that you only see the footprints that you are interested into by time, by snow cover, by cloud cover, by off-nadir, by whatever attribute you want to filter on. And we paired it with image mosaic so that you can use a stack catalog as the index for your image mosaic. So for example, this little image here, you can see in green the footprints of two images overlapping here. And then in red, the areas that are built up. So this is the world settlement footprints. It's a raster with, well, whether or not there are buildings in each pixel. And it's coming out of a stack catalog, which then points to rasters stored as cogs And the image mosaic is basically querying the stack catalog to figure out which images are in the area of interest, and then it's going to use the cog module to fetch those images from S3, from HTTP servers and whatnot, and it will generate a map for you. In a similar, with a similar idea, we have this new vector mosaicing data store, which is, let's say, an old idea that became new again thanks to the cloud. So the idea is that instead of storing a massive amount of vector data into Postgres, you actually store smaller amounts categorized by time or by area or by whatever other attribute you want to use. And then you can either store these smaller files on the file system, or if you are using flat GeoBuff or another format which is cloud friendly, you can store them in S3. Why is this? And then you index them pretty much just like an image mosaic in a database, where each record points at one file. When we are looking for to cover a certain area or a certain time, we are going to query the index, find the files that we need, and then go open only them. Now, why is this interesting? Well, cloud is great to manage larger and larger amounts of data. However, it gets pretty expensive when you start having hundreds of billions or hundreds of millions of records in a database. The cost of storage, the cost of the managed database goes through the roof. And if your use case is really picking up a smaller amount of data, like say, for example, you're doing precision farming, and you need to collect data in vector format from a field, and some of this data is in vector format, well, that information is timestamp, and it's for a particular customer, and your use case is really to provide that one customer an historical perspective on his field. So you really are going to open only a single field or a small amount of fields. You never need the entire data set. At that point, you can literally store them in a way cheaper, more cost-effective way in blob storage and use the index to figure out the file that you want without having to configure millions of layers in GeoServer, which we all know is not particularly efficient. It slows down the startup of GeoServer. It increases the memory usage. It's typically better to have as few layers as possible in GeoServer. So this one hits the mark in terms of keeping the number of layers small while still managing a massive amount of data on a cheap solution. Okay, let's switch to services. What's new in terms of services? Well, in GeoServer 2.21, the GeoPackage output community module became an extension. So you can now find it among the downloads for a released version. It's a GeoPackage output for WFS and WMS. For WFS, well, it's gonna dump into the GeoPackage vectors. For WMS, it's gonna produce a set of tiles instead. And what we left in community is a WPS process that can do the same with very fine-grained support, like deciding which layers you want to stick into the GeoPackage, and a number of experimental extensions, such as storing styles in the GeoPackage and stuff like that, which were part of a OGC testbed, but haven't become a standard yet, at least. The CSW ISO is probably the only module in the GeoServer history that graduated from community to extension, then went down from extension back to community, and then eventually came back to extension again. So the CSW ISO module is about handling ISO metadata records for the CSW protocol, which is a very rich, information-rich representation for CSW records. And as I said, it was part of the original CSW module, but then we didn't have a maintainer for it. It went down in community, and then eventually Niels Charlier from Shitus picked it up again, and it went back to extension status again. Along with it came the metadata module graduation. Now, the metadata module is is a module that allows to attach extra information to layers of your choosing. So you set up a YAML file that defines the keys and their type, and eventually how you want to edit them. And from this YAML file, the module will generate in the layer editor a form to enter these new fields. And you might wonder, okay, but I can collect more information about the layer. Then what? Well, then I don't have a slide for it, but you can use the template mechanism in CSW ISO to expose that information in the CSW records. So let's say before metadata, you could expose all the information that GeoServer had, but not anymore. With the metadata module, you can literally add whatever extra information you want and also stick it into the CSW ISO output. Another novelty for WPS is the KML output format. Talking about KML in 2023 might seem strange, but it seems that KML and Google Earth are still in use in a number of organizations, especially in military and the like. And so we got sponsoring to implement a KML output format for WPS, which can be used as a general output format for WPS processes, and in particular for the WPS download process, which is a extension allowing you to perform large downloads using the asynchronous support provided by WPS. Finally, you probably know what MB tiles file are, but just in case, MB tiles are SQLite databases filled with tiles and the tiles that make up the tile hierarchy of one layer. There are tools to generate them out of imagery, out of mapping data, whatever. What you can do now in GeoServer and GeoWeb Cache is to take one of these MB tiles, which has been already generated, and make it a GWC layer that you can then publish through WMTS. So it allows you to pair external tools that produce MB tiles with GWC to provide an OGC compliant service on top of the MB tiles file, rather than, well, the classic XYZ service that you would provide with the MB tiles oriented tools. Finally, and this is literally news of today, when you customize the attributes, you can now also edit the description of an attribute. And if you have column comments in your database, those will be used as the default for the description. And where does the description pop up? Well, in the describe feature type response of WFS. So classically, we just reflect the structure of the database and say, oh, we have this attribute with this type, this attribute with that type, and so on and so on. Now we can also provide a description of what that particular attribute does in the describe feature type. And as I said, the ability to edit such a description is a pull request that is being reviewed literally today. I reviewed it this morning. And will be likely in 2.22.3, like the next 2.22 release. Okay, let's switch to configuration and setup. configuration, the first thing that you will notice when you download and install a GeoServer 222 is the new welcome page layout. You probably remember that we classically have had the list of services in a column on the right with the service and the version, the service and the version, and so on. Now it looks like this, with the description taken from the service description panels that you have in the administration, classified by service, providing the various versions. And interesting enough, it exposes an ability that GeoServer has had for, I don't know, more than 10 years, probably more than 15, which is the ability to expose a service that is workspace specific or even just layer specific. A workspace specific service is a service that only contains layers from that workspace. A layer specific service only contains that one layer, or if it's a layer group, the layers in the layer group, which comes in handy when you have particularly large catalogs. Say that you have a catalog with 20,000 layers and you want to provide your poor ArcGIS or QGIS something manageable. Well, through these selections, you can give them capabilities documents which are a little bit more restrained. With this new welcome page layout came an interesting realization. So we had this customer, which is undisclosed, which has a very large catalog, 20,000 layers. And per se, that's big, but by far not the biggest that we have seen. I've seen servers with 200,000 layers. I've seen servers with 1 million layers. What makes this server interesting, it also has 40,000 security rules. So basically each layer has 2 rules, one for read, one for write, controlling access to that layer. Now, it became evident that this setup was very, very slow because the home page was taking forever to load. Why? Because the home page now has to fill these drop downs with all the workspaces and all the layers. And it's also counting how many workspaces and how many layers you can see with your current selection. With this particular installation and server, it was unbearable. It took minutes. So we did 2 things. First of all, made the home page gracefully degrade to simple text boxes in case there are too many layers or too many workspaces, but also made an interesting discovery in the security subsystem, which turned out to be the source of the slowness. And we made that one part, filtering the layers, 2 orders of magnitude faster. So we went from minutes to display the home page, but also to return capabilities documents, but also to provide the contents of the preview page to a few seconds. So 200 times speed improvement. Of course, you will not see it in the general GeoServer in the wild. You need this massive amount of security rules to actually enjoy the improvement. Still, for this kind of installation, it's quite a significant improvement. Another thing that we had in 221 and 222 is a language chooser. And here there's a little story behind it. GeoServer used to have the English language by default, and it was choosing which language to show the user interface based on the browser language. And I always look at the GeoServer interface in English. The Italian translation uses terms which are clumsy, at least to me. And so I had this promise or joke, if you want, that the day that the Italian translation would pop up in the user interface, I would make a switcher to choose the language so that I could go back to English. And well, in 222, it actually happened. We had the Italian translation go in, and we had a translation team asking for a better support for switching languages. So I implemented in my own spare time a language switcher so that you can choose in which language you can see the user interface. The province of Bolzano in Italy also sponsored an interesting improvement in terms of multilingualism. Now you can provide a good amount of the configuration elements for GeoServer in multiple languages, such as titles and abstracts and keywords and stuff like that. You can enter them in multiple languages, and then you can use the language parameter, which is not from OGC, it's from the Inspire specification, to choose which language you want to use in a get capabilities document, or in a get map, or in a get legend graphics. And there is a bunch of machinery that undercover allows you to decide how to do things. Like for capabilities, we only pick the titles and abstract of the chosen language. But for example, in getmap, there are functions which can be used to figure out in SLD what's the current language and decide, I don't know, which attribute to use for the labels in the map, for example. The styles page now reports the format chosen for the language, for the style language. So by default, GeoServer supports SLD 1.10 and SLD 1.1. You choose SLD 1.0 if you follow the classic documentation. You choose SLD 1.1, well, basically if you're editing the styles using QGIS, for example, but there are pluggable languages like CSS, YSLD, MB styles, and you typically have in the same installation multiple languages going. So now the styles page reports which format has been used for each and every style. The information was already there was not displayed. Now it's visible. The server status page is a page that you probably have visited more than one time if you are administering a GeoServer. There has been some improvements in it, general cleanup of label contents and buttons of the status tab, but also at the end, this JVM console tab, which is new in 2.21, which allows you to run a JStack and a JMap outputs. Why are these interesting? Well, JStack allows us to see a thread dump, which tells us what GeoServer is doing code-wise. Comes pretty in handy when you're trying to figure out why GeoServer is chewing CPU nonstop, because you can see what the threads are doing. And also, if you think that GeoServer is using too much memory, you could have a heap dump instead and get a summary of which classes are using most of the memory in GeoServer. So improved debugging without having to go into the server, get into the right user, and then run the same tools manually. Another thing which has been requested a number of times, and it's new in 2.22, is the ability to reset a single store or a single layer. So if we go back to this page, you probably know this clear and reload button. The reload button allows to reload the entire data directory definition, and the resource cache basically drops all the data stores so that they are recreated and they look again into the structure of the tables in the database, the structure of the rasters on disk, and so on and so on. All information that is typically cached because it's expensive to look up at each and every request. Now, through automation, you might want to change the structure of the tables, change structure of the rasters and whatnot. And if you have a large catalog, it can be expensive and annoying to have to reset everything just because you changed one layer. So this new REST endpoints allows one to reset one particular layer, the one that you have performed changes onto, like added or removed columns in the database, without having to drop everything else. Logging is another big topic. We have had around the 221 the big Log4j2 upgrade because of a potential security vulnerability which was actually not particularly applicable to GeoServer. Log4j 1 had a vulnerability if you were using a logger that was talking to through JNDI or through other remote mechanisms, which GeoServer was not really using, but we took the occasion. We had a few sponsors reported here, and we basically switched wholesale GeoServer to Log4j2. And this comes with a, well, better maintained library, better performance, especially if you are using a high logging profile. Suggestion, when you are in production, always use production logging. Otherwise, your server will spend more time writing logs than producing your maps. But when you actually need the extra information to debug something, Log4j2 is a good help in that. It performs the same job as Log4j1, but faster. There's a REST API now to control the logging level. It wasn't there, but we added it in around 220. Request logging, which is the ability to dump in the logs the URL that has been requested, eventually the body of the request. It has been there again for the longest time, 10, 15 years, but you had to go and modify a flag in web.xml and then restart GeoServer, which was annoying. Now you can do the same going through the global configuration panel in GeoServer. And you have checkboxes to enable, disable, request logging, enable, disable, body logging, and so on, and request headers. Which again comes pretty in handy if you're trying to debug what's going on with your server. Security vulnerability, topic of the week. First of all, we have people trying to contact us about real or potential or imagined security vulnerabilities through all sorts of channels, on Twitter, on the bug report system, on Gitter, by private email. Don't do that, please. We have a dedicated mailing list that you can post a security vulnerability to. So please always do responsible disclosure when you need to communicate a potential security vulnerability to us. Here is a summary of potential and actual security vulnerabilities that we have been dealing with lately. So Log4Shell was actually not something that GeoServer was actually vulnerable to, not that we know at least, but we upgraded to Log4j2 anyways. Spring4Shell was another big attack vector in the wild, but in fact, we found no way to use it in GeoServer. That said, we upgraded Spring. We managed to find an actual remote code execution in JNDI lookups, which might or might not concern you. It is concerning if you are giving a GeoServer in hosting so that the administrator of GeoServer doesn't actually have access to the machine. So in that case, it's actually a vulnerability that is of concern. You had to be administrator to set up JNDI strings for the connection pools. And in that case, yes, you could have managed to execute GeoServer, to have GeoServer execute code on the server side. But again, as I said, you needed you needed admin access first. So if in your typical deploy, your admin access also has console access to the server, well, it's got much better tools to execute whatever they want. The vulnerability is really there only if you are a hosting provider and the administration doesn't have console access. We found a remote code execution in GFL the map algebra language that we ship by default in GeoServer, and that caused the generation of our first ever CV report. And there was a mitigation. You could just remove janino.jar from your webbing flib, and well, you would have lost GFL, but also the vulnerability. And recently, like last week, we made a large bunch of releases for a SQL injection vulnerability that has been there since 2005 at least, but was really hard to spot because it was actually a bug in some code that was doing escaping to avoid the SQL injection. And well, it took several years to find out how to leverage it. For this one, there is no mitigation. You have to upgrade GeoServer, and we provided the releases of GeoServer from 2.18 up to 2.22. If you want to keep up to date with security vulnerabilities in general, you can go to our website, geoserver.org, look at the blogs. There is a security vulnerability tag that you can follow. Community building. This is a plea to all listeners here. The GeoServer project care and feeding relies on a low number of people. What is care and feeding? Well, care and feeding is answering to users' questions on the user list or on Stack Exchange. Care and feeding is performing the monthly release, which is not paid typically by anyone. Care and feeding is testing releases, which very few people do. Care and feeding is writing tutorials and documentation, which anyone can do, but typically only developers do. So what are we trying to do? Well, I'm trying to reach out to you for more active participation in the project. If you have been using GeoServer for a long while, you probably have a host of knowledge about the GeoServer and how it works. And you should be able to answer some of the questions on the user list on Stack Exchange. If you do, please do so. Help out. We have been reaching out to downstream projects to test release candidates, but I'm also reaching out to you when we push out release candidates, which will we do in a few days for 2.23. Please download it and test it against your particular use case. GeoServer does many things. You can customize GeoServer in many ways. Many have combinations of extensions which are kind of unique to their setup. Please test release candidates against your particular setup. We have been revamping the service providers page to highlight participation. And we have been exploring small contracts and cost recovery code sprint models to do activities that no one else would fund, like the Log4j2 update, for example, which we basically reached out to the community and say, we would like to upgrade to Log4j2. It's a lot of work, please help us. And we got 4 companies sponsoring the work, which we are very grateful for. We would have loved to have more sponsors, to be honest. Looking ahead, what's cooking for the next few months? Well, the COG module, the Cloud Optimized GeoTF community module, is still in development. We are using it in production in a variety of cases, but there are still a few things that we would like to improve, like more blob storage options, caching of the contents locally, and other improvements. For example, I can think of a problem with reading binary masks in COGS, which should be fixed. And once we have this improvement going, we can actually graduate this community module to extension. So if you're interested into the module, please reach out to, if you have development capabilities, to the developer list and ask us how you can help. Or if you have funding and you're interested in the COG module, reach out to core developers to get these improvements done. The OGCPI community module is implementing the new wave of OGC standards, and they are simpler APIs. They are self-describing. They are based on RESTful and concepts and JSON. We now have an implementation of a few of them, and Features API is moving towards is inching towards graduation to extension. Just a Features API though. Again, if you have development abilities or have a vested interest and you would like to invest in those modules, please let us know. OGC API features, as I said, is inching towards graduation, and I hope that I'll see that module graduated by the end of the year, but it really depends on one side, when SQL2 is going to be finalized. SQL2 is a SQL derivative that is going to be one of the standardized query languages for OGC API features. And on the other hand, how much funding and thus how much time we can pour on those modules to bring them through to graduation. The GeoPackage community module could use improvements. We have a couple of things that are pretty interesting. GeoPackage can store tiles, but it can also store generic grades like digital elevation models or concentration of pollutants, wind maps, and the like. It's part of the standard. It's not implemented in GeoServer. We would like to find someone that either wants to code it or wants to sponsor such functionality. And given that GeoPackage is very extensible and it has a number of registered extensions at the standard website, if you're interested in one of them, again, if you want to code, let us know. If you want to sponsor, also let us know. Another interesting newcomer is the WebP output format. WebP is an image format by Google that is supported in most modern browsers. It can compress images quite a bit more compared to PNG, although at the time of this presentation is quite a bit slower to be encoded. So it's a trade-off. It takes more time to generate the WebP, but then the output file is smaller. So it's very well suited for tile caches where you write down the tile once, but you reuse it many more times. And we actually know how to make it faster, like encode in less time than today, because, well, we have some magic going on in the PNG encoder that is very efficient and smart about extracting pixels and putting them in the PNG file, which we know hasn't been implemented for the WebP. So again, if you're interested in the topic, I can point you at where the code is if you want to develop, or please let us know, and we can do that kind of improvement for you. And literally, we can do whatever else you want to push for. The GeoServer community really doesn't have a roadmap. People often ask me, what's cooking in GeoServer? Or when will this feature will be implemented, and so on. But the GeoServer really doesn't have a roadmap, because the GeoServer PSC really has no pot of money to control to implement a roadmap. Like, we could have the ideas, but then coding them takes time and does money. The core developers are mostly employed in companies providing commercial services, such as the core developer companies. And what sets the direction is really the customers of such companies. So, and then we have a host of other developers that pop up occasionally to provide their own specific improvements to the server. So please, if you can develop, step in, prepare a pull request, discuss with us on the GeoServer Dev list. And if you have an idea and you got money, get in contact with the core developers and have them implement it for you. And with this, I am finished and I will accept questions. Ryan, is there anything you want to say before we move on?
No, we do have several questions in the Q&A, which we'll address. Thank you for everybody for staying, staying past the hour. We'll go through these questions. Some great information on GeoServer 222 and upcoming 223 release. Obviously, security vulnerabilities are all the rage these days, and the emphasis on the community and participation in the project is very clear. And obviously, the community is at the core of what open source is. So, we highly encourage involvement from everybody, and however we can support everybody, that's key. So with the questions, I will read these out loud if that works. The
Yes.
first question,
Go ahead.
Okay, is there a recommended procedure for transferring services to a newer GeoServer version when upgrading?
Yes, there is. If you look into the GeoServer documentation, there is a section talking about the GeoServer data directory. And the recommended way is that you start with the GeoServer having an independent external data directory, which is not part of the install. And then you make a copy of it, a backup. You install the newer version of GeoServer and point this newer version to the same data directory. Since we tried very hard to maintain backwards compatibility, it should be just working. Like even a 10 years old data directory should be working with the newest version of GeoServer. Caveat emptor, there might be bugs that prevent it, but as I said, we make an effort to be as backwards compatible as possible.
Excellent. And a kind of a sub question: are there any recommended scripts for data migration? And this particular user is trying to jump a couple of versions, and they're finding that migration, the data directory transfers some unwanted settings. So they're looking for alternative procedures.
No, not really. You typically just, as I said, backup or zip or find another way to transfer the data directory. Like many sites where they have a proper separation between configuration and actual data, like the data is outside of the data directory and the data directory only contains the configuration of GeoServer, which makes it relatively small. They manage that data directory into version control, like Git. Periodically, they commit the changes that they made into Git, so that they have a versioning and history in addition to backup. And then they either check out the same data directory on another server. And this is especially useful for a use case where you have a staging server where you try out your changes, and a production server where you actually do the production. And you do all the changes that you want in the staging server. Once you are happy with all the new layers and configurations and metadata and whatnot, you commit the changes you made to the data directory, and then you check them out in production, reload the data directory, and there you go.
Excellent. Thanks, Andrea. The next question is inquiring as to whether the OGC filter injection vulnerability has been addressed in 222.1.
No, you need the GeoServer 222.2. If you go at geoserver.org, here, there is a full statement about the filter injection vulnerability, including the list of releases where it has been patched. So 222.2, 221.4, and then even if they weren't supposed to be released anymore, we did an extra release of 220, 220.19, and 218. So these are the releases that received the patches last week.
Roger that. Thank you. The next question. Is the mosaicing also improved for cloud optimized GeoTIFF or TIFF only, or independent of file format?
The mosaicing improvements that I was talking about in, let me find it, this slide here. This one, are format independent. So it doesn't matter if you are talking about a COG, a TIFF, a JPEG 2000. What we improved is the actual machinery that puts together the images in memory.
Excellent. Next question is from Gabriel Osato. The making of mosaics with hundreds of images is made by GeoServer or a database in the background. I guess, is the making of mosaics with hundreds of images made by GeoServer or a database in the background? And the same question
always
is applied to
GeoServer.
hyperspectral. Okay. And
The
same with hyperspectral.
Same with hyperspectral. All the image composing and processing is done internally in GeoServer. GeoServer used to have a couple of modules to access rasters in the database, like Oracle GeoRaster and PG Raster, but they didn't have enough traction, like and not enough people used them, and we literally didn't have any customer asking services around them. So eventually we had to drop them because the original implementer left, and there was no business around the modules to justify getting a new developer, learn all the details about them, and then supporting them.
Understood. Thank you. Another question, will it be faster to load cloud optimized GeoTIFF from a cloud storage, for instance, Google, versus accessing the same file on local disk?
No, it's actually the opposite. It's faster to, it's typically faster to load from the local disk, but having an actual local disk on the cloud is very expensive. So if you need to support massive amounts of raster data without breaking the bank, you typically want to store them in the cloud. That said, we made a significant number of tricks and improvements in the cog reader to make it as fast as possible. So, for example, cloud storage like S3, Azure Blobs, and so on typically has a nasty delay. So it's slow to, get the first byte in. You have to wait. But then the throughput is pretty good. So in order to optimize performance for the cog case, once we figure out which tiles we need, so which portions of the file we need, we actually make all these requests in parallel. While on disk, we would typically do them sequentially. So we compensate the initial slowness of communication of blob storage by parallelizing access. It's a good trade-off because on disk, disks typically do not like having a massive amount of parallel requests happening at the same time, but blob storages kind of like it, especially the Google storage is designed so that the more parallel you are accessing it, and the better it performs. Like they shard the data in a different way. They provide more hardware behind it, and it just goes faster. So the more you parallelize, the better it goes.
Excellent. Kind of maybe a related question. Will accessing the cogs through Stack be slower than accessing the same cogs through GeoServer directly?
Same as above. So it depends on the topology of your solution. So if you have GeoServer running on your laptop and you are accessing a remote Stack server, and also the images are remote, you're gonna pay the price of all these remote requests over potentially slow network. But if instead you have GeoServer, the Stack server, and the images all co-located in the same region of the same cloud provider, then the price won't be that bad. It's not going to perform as well as the classic Mosaic with local files, but it should be pretty good anyways. The thing is, you have to keep everything together in a network where communication is blazing fast. So typically, same region, same cloud provider.
Got it. Thanks, Andrea. Next question, can you disable the welcome page?
No, you cannot disable the welcome page. What you can disable is the entire web administration interface. There is a flag that you can set startup time that kills the entire administration interface. What you can do if you want is to use a proxy to achieve that goal, so that you leave /AWS/WPS/WMS and so on open to the internet, while you make access to /web, which is the administration interface, closed to the internet but open to your local network, which is something that several people do to avoid any sort of attack. Like they close down /web and /rest so that you cannot do any sort of administration activity from remote. That's one thing. It's also possible to just kill and remove entirely the web interface and the REST configuration API from the GeoServer WAR. Like you go and remove all the GH-web and the GH-rest jars, and you have a GeoServer that's still running and working, but it doesn't have any ability to reconfigure the GeoServer. So all that you can do is written in stone in your data directory, which is an approach which is chosen by, for example, military grade deployments, where no one has the ability to touch the configuration.
Got it. And if that's something that we can help out with, obviously we're here to help support or provide some guidance on that. Andrea, I don't have access to the chat, but I was thinking if you want to provide like the info at or my contact, my email, that might be useful for the attendees.
Yep. Zoom is playing tricks on me on this Linux machine, and I don't seem to.
I can only chat directly with you.
Yeah.
But in any case, it's info@geosolutionsgroup.com.
Yep.
Or first.lastname@geosolutionsgroup.com. And you obviously you can access
I can type it in the slide.
Okay, cool. Next question, will the recording be available for later viewing? Absolutely. All of our webinars are posted on our YouTube channel, and will likely also be posted to our blog as well. But if you search GeoSolutions Group YouTube, you'll find our YouTube channel, and there you will find a full stack of resources, not only on GeoServer presentations, but MapStore, GeoNode, and other educational presentations we've provided in the past. Next question, are there any plans for a more modern UI on the admin interface?
This is the slide that contains the answer. We don't have any customer asking for it right now. If we manage to find anyone that really wants to sponsor, I don't know, a JavaScript-based user interface or something like that, we will do. And if you are interested in doing it yourself, jump on GeoServer Devel and let us know about your plans. We are happy to support a different user interface, maybe initially as a community module or as an extension. And if it ends up being better than the older one and easier to maintain, then we will adopt it as the default one.
Excellent, thank you. A great question about getting involved. Kate Maya is a GIS developer and would like to join the community to help out. What's the best way for her to reach out, and she provide her email address?
Okay, so if you go to geoserver.org, there's community and there's community support here. And we are using mailing lists for communication. You can subscribe to them and start answering questions, or, well, just see what goes on. At gis.stackexchange.com, there's a tag for GeoServer, and you can help answering questions there. Sorry, not here. Docs.geoserver.org has this documentation manual, which teaches you how to write documentation for GeoServer. And literally, if you go to any page in GeoServer, there is this edit button that you can follow, and you can, well, right now I'm not signed in, but you can use this pen to edit the contents of the page, and then GitHub will do a pull request for you. So that's one way to contribute with documentation. And generally speaking, like if you have a tutorial or something like that, and you have your own blog or your own publishing facility, it's always appreciated if people write how-tos and like, and then link them on Twitter or some other social so that other people can reach out or post their location on the GeoServer user list, for example.
Excellent. That's what I was going to suggest is getting on the GeoServer user list, which I'm assuming is also through geoserver.org.
Yep.
Great. Thanks, Andrea. What's the best solution for importing multiple ECW files to GeoServer?
Not importing ECW files? Okay, that was half a joke. So using ECW files in GeoServer legally requires a license from, what's the current owner of the technology? Ryan, can you help me?
That
Hexagon,
was,
I think.
Yeah, I
it
think
was
it is
Hexagon, I
Hexagon.
think. Okay, so ECW reading libraries are free for desktop usage, or used to be free for desktop usage. So you can use them from ArcGIS, map, from ArcMap, from QGIS, and that's free and legal, and it's working fine. If you start using them in any server product, GeoServer, map server, Degree, pick your choice, then they will still work, but it's illegal. You actually have to buy a license, which is pretty expensive as far as I know. That said, if you have a license, then GeoServer, the GeoServer GDAL plugin can read ECW files. And if you have a lot of them to publish, then you probably need to perform some sort of automation and use the REST API to do the job of configuring all of them en masse. Again, if you can, try to use an image mosaic of ECWs, because especially if they are covering the same, same area, or if they have a time perspective, but the area is the same. Generally speaking, try to use a mosaic rather than having thousands and thousands of layers. In both cases, you can use the GeoServer REST interface to write a script that will import all of the ECWs for you in GeoServer.
Excellent. I'm assuming there's also a way to decompress or export ECW out to GeoTIFF in some way.
Yeah, well,
that's a better
GDAL.
workflow. GDAL, okay.
You typically GDAL, and right now GDAL has this COG output format which automatically generates for you a COG with overviews and the like.
Excellent. And again, as always, with all the questions, if we can be of further assistance on these, just reach out to us and let us know. We can provide more guidance and more detail. Next question. How can I contribute to GeoServer? This is a funding question from Ite Baron. Apologies if I mispronounced your name.
There are two ways. If you just want to contribute and let us decide what to do with the funding, the geoserver.org has a donate button at the bottom of the page. And you can deliver whatever amount of money you want using PayPal or a debit or credit card. In case your organization needs an invoice, you can contact, let me see if I can find it here. We don't have a link here, but here. If you follow this OSGeo link, it will throw at you at email address treasurer@osgeo.org, and you can discuss with the OSGeo treasurer about providing an amount of money and receiving an invoice for it. If instead you have a very specific idea of what you would like to donate and what you would like to get implemented, you can also reach to the commercial support contributors, in particular the core contributors, and get a quote about how much it will take to implement your desired feature.
Excellent. And again, if you need some help finding that, Ite, just let us know, and we can help guide you through that process. Next question, does it support lower version upgrades? It's a little bit vague.
Lower version. I mean, generally speaking, as I said, you can take the GeoServer data directory, you back it up, you upgrade GeoServer to a newer version, and you point GeoServer to that same data directory. The data directory is the key. It contains the whole configuration of GeoServer. And so all you have to do is to swap in the old data directory into the new GeoServer, and the new GeoServer should be able to read it. Just one thing, always make a backup, because in case you decide you don't like something in the new GeoServer, if you try to go back and the new GeoServer has modified something in the new data directory, the older GeoServer might not be able to read it anymore. The ability to move is upwards. So you move from an older version to a newer version, typically without problems. If you let a newer GeoServer touch a data directory, the older version might not be able to read it anymore. So
Okay,
always
excellent.
have a backup.
But hopefully that addresses the fundamental part of that question. And again, if you have additional questions or run into any problems with upgrading, let us know and we can provide some guidance. We have some compliments on the presentation. So thanks, Andrea.
Thank you.
For your expertise. Final question, will it be possible to add new CRSs to WMS API implementations?
New CRSs, yes. So GeoServer is currently limited to the EPSG authority. So you can add the new codes, but they will appear under the EPSG authority. And let me see, GeoServer customize CRS, custom CRS definitions here. So this is the page, custom CRS definitions in GeoServer. You can start simple, like you have a WKT text describing your custom projection. Sorry, your custom coordinate reference system definition. Hopefully the projection is already supported by GeoServer. If not, it can be added, but you have to write code to support the extra projection. So it's a matter of yeah, get in touch with us if you want to code it yourself, or again get in touch with core developers to have that particular projection implemented. If it's just a matter of configuring a CRS with a known projection, but just set up the parameters in a different way or the datum in a different way, then there's a file that you can edit to add the projection. And you can even override an official EPSG code if you want. And you can also configure the way you go from one coordinate reference system to another in a custom way. Like GeoServer typically tries to do its best to get the most accurate way to transform it between two coordinate reference systems, but you might know better, or you might have grid shift files that provide high accuracy datum shift offsets. And you can configure the grid shift files. You can configure your own custom transformation if you want, overriding a configuration file, the EPSG operations.properties, telling GeoServer how to do that particular transformation between two codes of your choice. So yeah, there's a good amount of flexibility. We also have knowledge that there will be sponsoring to implement support for authorities outside of a PSG in the future. It's still uncertain in terms of if and when, but there is talk about it, so it might happen. Stay
Excellent.
tuned, and we'll eventually implement support for other authorities other than a PSG.
Excellent. That is a very hopeful, optimistic way to conclude. If there aren't any more questions from the audience, I believe that is it. Thanks again, Andrea, for the presentation
Welcome.
and getting into the technical weeds of GeoServer. And again, reach out to us anytime. If you guys have any questions, however we can support, we're here to support your open source usage and operations. So call us. And with that, we will conclude and sign off. Thanks again for your time, and have a great afternoon.
Yep. Bye-bye.
Bye-bye.